Hi guys, today we're going to do lesson 11.1, but we're going to start with some reducing radicals. This probably isn't completely new to you. You did it in Algebra 1, or at least you were supposed to. Okay, so this is without a calculator. We put that out there because we're going to do this a lot and you need to know how to do this. This is on iStep, SATs, all kinds of tests. So it's a skill that you definitely need to know. All right, now basics. If I asked you the square root of 25, most everyone knows that the answer is 5, or you might even say plus or minus 5. The reasoning behind that is because the square root and the square cancel out each other. And because they're like inverses. And so that's why the answer is 5. So we're going to put everything in groups of powers of 2. Which means we need to do factor trees. And I have an alternate method I showed my Core 40 class this year because I find a lot of kids lose numbers in the factor tree, like they just forget about certain numbers. So this is a nice method. Now, this method only works if you use prime numbers. So, and for instance, 2 is prime, and 2 goes into 90 45 times. And then what goes into 45? Well, 5 does. And then you say, okay, what goes into 9? 3 and 3. It's kind of nice because all the that's kind of dark. All the prime numbers are out here and much easier to keep track of than a factor tree. Yes, you could do a factor tree, 90, and then that way you don't have to use a prime number. Now, my tree, all the numbers are here, but sometimes the tree is like very lopsided and it's easy to lose numbers. But anyway, I realize there are other ways of teaching this. Some people like to pull out perfect squares, and I don't teach that method. If you like that method, you can do that. Here's the way I teach this. I take and I line everything up, and I say, okay, I have a 2, a 3 squared, and a 5. And they're all being square rooted. The square root and the square cancel each other out. So that means the 3 gets to come out of the square root. So it breaks out. But these 2 are left over, so you have to multiply those back together. So the 3 is on the outside, and the 2 and the 5 multiply back together to give you 10. Now, we're not quite finished, right? Because we have to deal with these x's and y's. But x's and y's, variables are easy. So if you have a group of 2, they get to come out. So technically, let's add it to our list. You have x squared and you have a y. The x gets to come out of the square root because there were 2 of them. But the y has a power of 1, so it stays inside. So my final answer, I already have it, 3x square root of 10y. Now, the nice thing is you can check it. Take the numbers on the outside and square it. So 3 squared is 9. 9 times 10 is 90. X squared and y is x squared y. Please ignore that message or announcement.
That way we can keep people socially distanced outside. Additionally, if you are a first wave bus rider.
Okay, next up, we're going to talk about 48. So let's do 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. Okay, so we have one group of 2s, 2 groups of 2s, and a leftover 3. So 2 squared, and a 3. And then we have all the variables. A squared. Now, b up to the 4th. Now, guys, I'm going to just hold up and then talk about the variables here in a second. Now, this 2 is going to get to break out. The next 2 gets to break out, and they are connected with multiplication. This 3 does not get to break out because it's a power of 1. Okay, so far we know a 2 and a 2 come out, and you can go ahead and multiply them if you want. So there's a 4 on the outside, then on the inside is a 3. Now let's deal with the a's. Does it get to come out? Sure, because there's a square root and there's a square, so the a gets to come out. Now, when you're doing numbers bigger, like a power greater than 2, it's very easy. You just say, how many times does 2 go into that number? So how many times does 2 go into 4? Twice. So 2 b's come out. Now, when it's an odd number, you're going to say, how many times does 2 go into that number evenly? 2, 4, 6, 3 times. So why did I put it 2? 3, and then there's one little c left over. Because remember, you can check this. Square the number is c to the third, and then you square that and get c to the sixth, and you add this other one, so you get c to the seventh. So it works out. So guys, this is a final answer. Again, you can check it, square what's on the outside, and multiply it with what's on the inside, and you should get your final or your original question back. All right, now this last one that we're going to do, there's a 3 that's hanging out, and we're just going to bring it along for the ride. You really don't have to do anything special with it. So let's take 84, and then you get to decide what you want to go into 84. I know 42 goes in, or 2 and 42, and then 2 and 21, and 3 and 7. Okay, so 2 squared, 3 and 7. All right, so what gets to break out? Well, this first 2 gets to break out, but these have to stay inside because there's only a power of 1. Okay, now, the only issue here is there is the 3 that's in the front. So there's the 3 that's in the front, the 2 that you just brought out, and the 21 stays on the inside. So let's do this exponent. How many groups of 2 do you have here? You have 6. So you have x to the 6th. And let's do the y. So this is y to the 3rd. And then now we have 6, x to the 6th, y to the 3rd, square root of 21. Okay. Now, next we have theorem 49. The altitude to the hypotenuse of a right triangle forms 2 triangles similar to it and to each other. All right, guys, so we know what altitudes are. We've been dealing with those like since the area and surface area chapter. It comes out of a vertex straight down and it makes a 90. So that is my altitude, okay? Now, it creates 3 triangles that are similar. Now, we're going to start writing similarity statements. So there's 3 triangles. Let's start with the big one. Let's put it in any order you like. I'm going to just say A, B, C. And then we're going to have to finish this. Now, my order matters, okay? So try to write in the medium-sized triangle in the correct order. We need to follow suit of the first triangle. So A, B, C. So if this is my order, I'm going now. There's 3 lengths here. We have a short leg, we have a long leg, and we have the hypotenuse. So technically our order is short leg, long leg, hypotenuse. So short, long, hypotenuse. Okay, now let's follow that same order. Short leg, long leg, hypotenuse. Okay, so down the short, then the long, then the hypotenuse. B, D, C. Now let's do the other side, the little baby triangle. So this is your short leg, this is your long leg, this is your hypotenuse. So let's go in the correct order. Down the short, then the long, then the hypotenuse. So this is A, D, B. Now, this is just one method. Now, some teachers teach it drawing out all the triangles. I personally do not prefer this method. I like the short, long, hypotenuse, or whatever the order is method, but I'll show you both methods. Now, the big triangle, is at S, that is the right angle. And then I usually say, okay, where's the short side? So that means this side has to go down to Q, and then the top angle's R. Now let's do the medium triangle. The right angle is the easiest. That's T. It goes over to the short leg to that angle, which is S. And so then the top would be R again. Baby triangle. Well, that side over there is the right angle as well. So that's T. And then let's go over to the short leg, which is Q. And then the top would be S. Okay, so if you like this method, you would draw this out every time and then see the order. So R, S, Q. So R, S, Q. This way is much more visual. So the next one is going to be R, T, S, and then S, T, Q. Now, if you like the other method I was explaining to you, you would say, okay, what order is this? R, S, Q. So down the long leg, then the short leg, and then back home on the hypotenuse. So long, short, hypotenuse. Now you have to erase those markings because for each triangle it changes. So for the medium triangle, this is your hypotenuse, short, and long. So if I go in long, short, hypotenuse order, go down the long, then the short, then the hypotenuse. So R to T to S. And if you notice, that's exactly what I have. And you would do the same for the last one. Look at the baby triangle. Down the long, then the short, and the back home on the hypotenuse. So S, T, Q. All right, so you guys pick a method. The order matters. All right, so now we have a corollary 1. Now there's more than one corollary, so make sure you say it's corollary 1. The altitude to the hypotenuse of a right triangle is the geometric mean. Boom. Okay, we've had this word before. Last chapter, I just wrote out problems like find the geometric mean. Well, my pen's not working. Between 10 and 25. And so you were taught to make a proportion, 10 and 25, cross multiply and solve. Guys, it's no different now, okay? So the only difference is that it's in picture form. When the geometric mean is this piece in the middle, it takes your hypotenuse and breaks it into 2 parts. So later when you're confused, you don't know how to do it, and you ask, I'm going to say this is a part question. Okay, so the geometric mean goes in opposite corners. Those are usually a variable. They don't have to be a variable though. And then the 10 and the 25 would go here and here. Okay, now the last chapter you could give me decimal answers. Now I expect radical answers. So x squared equals 250. We're going to square root it. And we have to either do a factor tree or that new method I was showing you. I can't do 25, so that's not prime. So I'm just going to do a factor tree. 25 and 100 and 5 and 5, 10 and 10, 2 and 5, 2 and 5. And I just realized I can't multiply because somebody just walked in the room and I got distracted. Sorry. It's 25 times 10, so that's 2 and 5. All right, that sounds much better. Okay, so we have x squared equals, let's see, a 2, and we have 3 5s. So guys, what we're going to do is we're going to put a group of 2 and then a leftover 5. So the only thing that breaks out is this one. So the 5 breaks out, and then the leftovers go back together. So it's a 10 on the inside. And I forgot to take off that little power. Now this is a part. We have a corollary 2 that I'm going to call something else. Okay. This is called a part whole. And I'm going to explain to you why this works. And then you never have to do it this way again. Okay. I used to teach it this way when I first started teaching. And it's much longer and tedious, but I'll show you a little shortcut. The way he worded it's really awkward. So I'll just explain to you how this works. The geometric mean is an altitude, and an altitude is where a segment comes out of the vertex straight down and it makes a 90. So technically that's an altitude, which is a geometric mean, or this side as well. So really, you could have 3 different geometric means. Any of these 3 places here. The hypotenuse is never a geometric mean. So when it's in the middle, you have this way up here, the part, which is corollary 1. When you're trying to find a leg, this is corollary 2, and I call it part whole. Now, what I did is I drew the triangles out, and it looks like I accidentally erased the top angle. That was a C. And that one was also a C. Yes. Okay. And what you can do is you can visually see what's happening. If this is my geometric mean, AB, this side here is technically part of 2 triangles. It's part of this baby triangle, and it's part of this big papa triangle, okay? So what you can do is you can write a proportion using that information. You can say, well, this X on the baby triangle corresponds with the 35 on the big triangle, and the 10 on the baby triangle corresponds with the X on the big triangle. Now, I realize the X's are probably not, they're in the extremes instead of the means, but the outcome is the same. X times X is X squared equals 350. And then square root it. So X is the square root, and now we have to do some work. All right, so let's grab a calculator. 350, let's just do like 25 and 14. You definitely don't have to use those numbers if you don't want to. That's a 2 and a 7. So I have a group of 5s, a 2, and a 7. So this 5 is the only one that comes out. So I have 5 on the outside, and these 2 go back together. So you get 14. All right, so that's your answer. Now, if you want to do it that way, there's nothing wrong with that way. That kind of explains what's happening the best. Now, I'm going to show you a method where it's much faster. Okay, so remember, each one of these are called a part, but this entire length is called the whole. Now, if you're finding this X, which part is touching X? Well, the part that's touching it is the 10, right? Now, the geometric mean is always diagonal. So the part that's touching it is the 10, and the whole length is 10 and 25, which is 35, which you can see is the same as what we had over here, but much faster. Now, what happened if I say that's y? You will get a different answer. My geometric mean is y, so I put it in opposite corners. The part touching y is 25, and the whole length is 10 and 25, so it remains 35. All right, so we're going to practice a few of these. Now, the first one here, let's just call this example 1. The geometric mean's in the middle. So this is just a part problem. So the geometric mean goes in opposite corners. So you have to understand what you're going to do now. You're going to take the 2 numbers, 3 and the 9, and just put those in opposite corners, the part and the part. So X squared equals, and then technically that's 27, but okay, let's just make it 27. We're going to take the square root of 27, and 27 is 3 times 9, which is 3 times 3. So you have one grouping, 3 squared and a 3. This 3 gets to break out, so it's 3 root 3. Now, same numbers, but we have the outside here. This is a part whole. So part whole. So it's a y and y. The part touching it is 3, and this whole is going to be 12. So y squared equals, I'm just going to multiply and get 36. And you guys know the square root of 36 is 6. Now, let's do x. That's not x. Let's do z. All right, again, it's part whole. The part it's touching is right here, which is the 9, and the whole is still 12, right? All right, so 9 times 12 is, I believe, 108. And we have to reduce it, 108. So that's 2 and 54. And 54 divided by 2 is 27. 3 and 9, 3 and 3. All right, so we have this grouping and we have this grouping. So those numbers come out, but the 3 stays in. So the 2 comes out, the 3 comes out, and the 3 stays in. So we're left with 6 root 3. All right, let's try these two. Now, you just have to decide, is it part or part whole? So go ahead and pause the video and see if you can do this next one. All right, so hopefully you've attempted this, right? So y is in between the two parts. So you're going to use the 6 and 14. Now, this is just me thinking out loud. I could multiply these together and then break it apart. Or I could just say, I'm multiplying them together, but 6 is 2 and 3, and 14 is 2 and 7. Just me do my mental math. It's easier for me just to break it apart instead of multiplying and then breaking it apart again. You do you guys. All right. Now, I see that I have 2 2s. So you guys know what happens, right? So you have 2 squared, a 3, and a 7. What comes out? Of course, that 2 does. So the 2's on the outside and the 3 and the 7 multiply to get 21 on the inside. So when we do the x, it's on the outside. So you're going to use the part that it touches and then the whole. So x squared equals 120. Now remember, you can multiply and then split it apart or just split it apart. So 6 is 2 times 3, and 20 is 2 times 10, and 10 is 2 times 5. You definitely don't have to do it that way. So there's a grouping. I think that's the only grouping. So let's square root both sides. We have 1, 2 comes out, and then the 5, 2, and 3 stay in. Now, this next one's a little weird. Now, when it's in the middle, it's a part, but usually it's an unknown, right? And the geometric mean always goes in opposite corners, but now my geometric mean is 32. So it goes in opposite corners. And the part are 9 and y. All right, so 32 times 32, I believe, is 1024. This one is different. You're just going to solve it by dividing by 9. So divide by 9. Ew, I got a weird answer. I'm going to check my math on this. 32 times 32 is 1024. Divide by 9. Yeah, it's just a gross answer. 113.7 repeating. There you go. All right, last question. And we don't even have to finish working it out. Just pause the video and see if you can set these up. We have X's, we have Y's, and we have Z's. All right, time to pause it and go. Okay. I personally like just doing the part and getting it out of the way. So the 2 parts are 4 and 10. So that means the x and the z are part wholes. The part here is 4, and the whole is 14. For z, the part next to it is 10, and then the whole is 14. All right, that is it for today. Please let me know if you guys have any questions.